In this video, we will solve a problem on input-output model, that is Leontief input-output model. The question is like this. Given the technology matrix as A is equal to this, we are being given the technology matrix and final demands, that is F1, F2 and F3. Find the output level if f1 is equal to 20, f2 is equal to 0 and f3 is equal to 100. Okay, so we are basically being given a Leontief input output coefficient matrix, what we call the technology matrix. And how do we solve this very question? Basically, by input output model, what we mean, input output model is a form of macroeconomic analysis based on the interdependence among the different economic sectors or industries. Okay, so it simply shows us the interdependence among the different industries in an economy. Okay, and how do we solve this very this type of question? So basically what we are being given, we are being given the technology matrix. And how do we interpret this technology matrix? Let me give a simple example. Okay, this is 3 by 3 matrix, but I will give you an example so that you can relate with this technology matrix of a 2 by 2 matrix. Okay, let us say we have two industries in an economy. Let us say we have steel industry, okay, and we have coal industry. I'm just trying to give the interpretation, how do we form this technology matrix, then I will solve this question. Okay, so it will make more sense. And let us say we have here again the steel industry and coal industry. Okay, let us say steel industry. Let me give you here some numbers. Let us say we have 8 here, let us say this is 7, let us say we have 12, let us say here it is 11, or we have also the final demand. Okay, so let me write here final demand. Let us say final demand is 10 and we have 9 here. I'm just giving the arbitrary numbers here. And let us say we have the total output here. Total output is 30, and let us say here is 30, any number, let us say it's 27. Okay, so actually this shows us the inputs required by each industry. Okay, and this shows us the outputs of each industry. And how do we interpret this very this very table here? Simply this ad shows that 8 units of steel are used by the steel industry for its self consumption. Okay, similarly this 12 denotes that 12 units of steel are used by coal industry. Okay, similarly 10 units of steel are being demanded by households, government sector or for export sectors. Okay, so 10 units are demanded by the government sector or the household sector, and total steel output is 30. You can see here 8 plus 12 is 20 plus 10 is equal to 30. So if steel industry is producing 30 units of output, 10 units of output is being demanded by the households or government sector. Okay, this is our final demand. And coal industry uses 12 units of steel industry, and steel industry itself requires 8 units of steel for its self consumption. Okay, similarly we have coal industry. If you want to interpret here, this 7 simply denotes that we need 7 units from coal industry as an input for steel industry. Okay, and here also this 11 shows simply that 11 units of coal industry are used by coal industry for itself, that means for self consumption. And also 9 units of coal are being demanded by households, government sector. And total output of the coal industry is 27. Okay, so 9 is the final demand by the government sector, household sector, and 11 is used by the coal industry for its self consumption, and 7 units of coal industry output is used by steel industry for its consumption. Okay, so this is our, you know, a table showing input and output here. Basically what happens here, let us say we have any industry. Okay, so we have industry. If we have the any industry, I'm just giving you an general idea here. So any industry will use whatever it produces, some part for self consumption. Okay, self consumption, and this particular industry will, you know, give output for other industries which they use for their input. Okay, so it also provides the output it produces for other industries. Okay, also this industry, whatever it produces, there will be some final demand from the household sector or government sector or export sector. Okay, and this total, if we add up these two, will denote the total output by this particular industry. Okay, when we add up this will be the total output by this industry. Okay, so any particular industry uses its some part of output for its self consumption. It also provides output for other industries, and also it provides the output for final demand, that is the demand by the households, government sector or export sector. And this total will be here, if we add up these two, it will be the total output. Okay, now what is meant by the technology matrix here? So let me also explain that very part, then I will be able to solve this question. So first we should have some basic understanding here. Now technology matrix simply shows us the, you know, what we call the input output coefficient also. Okay, it simply shows us to produce 1 unit of output, how much units of other industries output is required. Okay, so let me write it here. So if I want to draw the technology matrix of this very data here, what does it tell us? It simply tells us that to produce 30 units of output of steel, okay, we require 8 units of steel as input. Okay, let me write it here, or let me show it here also. Let us say we are producing 30 units of steel. Okay, if we are producing 30 units of steel, it requires 7 units of coal. Let us say 7 units of coal. Okay, now to produce 1 unit of steel, okay, we will need 7 by 30 units of coal. Okay, that is how we form the technology matrix. Similarly, if we are producing 30 units of steel here, 8 units are required to produce 30 units of steel. That means here we have 8 divided by 10. Similarly, if 7 units of coal are required to produce 30 units of steel, that means we will have here the share of, you know, it simply shows us the input, a share of input of one industry in the output of the output industry. So we have here 7 divided by 10, 7 divided by 30. Similarly, uh, 12 units of coal are required to produce 27 units of coal. Okay, so we will have here 12 divided by 27. Similarly, 11 units of coal are required to produce here 27 units of coal. So I will write here 11 divided by 27, and what we form here, it is called the technology matrix. That means, So this is it. How do we form the technology matrix? And it simply shows us to produce 1 unit of output, okay, how much units of other industries output is required. Okay, so if I want to interpret this 7 upon 30, so it simply tells us this very 7 upon 30 tells us that to produce 1 unit of steel, okay, 1 unit of steel, 1 unit of steel, we require 7 by 30 units of coal. Okay, it shows the percentage share of input of one industry in the output of other industry. Okay, this is our technology matrix, and actually this is what I want to convey here. Okay, so now we can go and solve the question. So let me rub this out. Now coming to the question, we are being given the technology matrix. First step is, I will not rewrite it here because I will not have I don't have the luxury of the space here. So first step is we form I minus A matrix, that is identity matrix. First we write the identity matrix, that is 1 0 0 0 1 0 0 0 1. This is called the identity matrix. To this we subtract this technology matrix. Okay, that is 0 0.1 0 0 0 0.3 0 0.2 0, then we have 0 0.1 0 0.2 0 0.3. Okay, when we subtract these two, what will we get? So 1 minus 0.1 is minus 0 0.9, and similarly when you subtract each element with its corresponding element here, so you will get so 0 minus 0 is 0, then 0 minus 0 is 0, we have 0 minus 3 is minus 0 0.3. Okay, similarly we have 0 0.8 here, 1 minus 0.2 is 0 0.8, then we have 0, so minus 0 0.1, similarly we get minus 0 0.2 0 0.7. Okay, basically what we want to find out, so let me write it also here. What exactly do we want to find out? Our endeavor is to find out a relationship, that is our x, which will be here x1, x2 and x3, that is the final output produced by each industry, should be equal to I minus A inverse into D. Okay, I minus A inverse, which we will calculate here. D denotes our final demand, so this D is actually F1, F2, F3. Okay, when we solve this, we will get the output level of each industry here. Okay, so first we got this matrix. Now to calculate this inverse, okay, to calculate this inverse, first we need to find out the adjoint. Okay, adjoint of I minus A. Okay, also we need to find out the determinant of I minus A. Okay, because let me write it here, this I minus A inverse is equal to 1 divided by the determinant of I minus A times adjoint adj, adjoint I minus A. Okay, so we have to use this very stuff here to figure out the solution here. Okay, now first step is to find the determinant of this matrix. Now the determinant of, let me write it here like this to differentiate it with the determinant symbol. So I minus A will be equal to, taking determinant of this is simply we write minus 0 0.9. Okay, we write first element and delete mentally this row and this column and take the determinant of the remaining element. So 8 sevens are 56, so we will get 0 0.56 then we have minus from the formula. I have explained this input output analysis in detail in earlier video. You can check that very video also. Okay, so we have minus from the formula, then we have minus 0.3. We take the second element and delete the row and the column corresponding to this element and take determinant of the remaining element. So we have, if we mentally delete this row and this column and this row, we are left with 0 into 0.7 is 0 minus 0 into minus 0.2 is 0. Okay, so we will get here 0. Then we have plus from the formula and take the third element, which is minus 0.1. Okay, I will not be able to explain all this stuff here because it will get lengthy here. Taking this element, deleting this column and this row and taking determinant of the remaining element. So 0 into 0 is 0 minus 0 into 0.8 is 0. So here we also get 0. Okay, now what exactly do we get here? So let us calculate here. So 0.8, so actually we got here 0.8 into 0.7, but I guess I have made a big mistake in the first place, because 1 minus 0.1 is equal to 0.9. Okay, so it is here plus, so 0.9 into 0.56 will be 0.504. Okay, we got this determinant I minus a. Since it is positive, so this system is feasible. We can proceed on to get the value of x1, x2 and x3. If it was negative, then this system was not feasible enough to do the further calculation here. Okay, since the determinant is positive, we can move further. Okay, so first step was to find out this I minus a. Now we need to find out the adjoint. Okay, so how do we find out the adjoint? First we need to find out the cofactor matrix. Okay, so how do we find the cofactor matrix? Let me write it here. So to find the adjoint, first we need to find out the cofactor matrix. And how do we find cofactor matrix? So this will be a tedious job here, because so cofactor matrix will be formed by, okay, cofactor matrix, let me show it here, will be formed by, okay, this is our I minus a matrix. To find out the cofactor matrix of this matrix, how do we form? Simple thing. First we delete, let us say we want to find out the cofactor matrix at the first place. Okay, so for this we delete this column, this row, and write these minors, that is 0.8, then we have 0, then we have minus 0.2, and we have 0.7. Okay, let me repeat it here. To find the first element of the cofactor matrix, we simply delete the column and the row in which the first element appears and take the determinant of the remaining elements. Okay, similarly, to find the cofactor at the second place, we mentally delete this row and this column and take determinant of the remaining element. So deleting this row and this column, we are left with 0, 0, 0, minus 0.2 and 0.7. Okay, so let me write it here. So another minor will be here 0, 0, then we have minus 0.2, and then we have 0.7. Similarly, to find out the minor at the third, at the third place, we delete this the corresponding column and the row and take determinant of the remaining elements. So what are the remaining elements here? We have 0, 0, 0.8 and 0. Similarly, this was they were at the first place. Now to find the minor at this place, we simply delete and the row and the column corresponding to this position and form the minor. So deleting this row and this column, we are left with minus 0.3, 0, minus 0.1, okay, and 0.7. Let me write it here. So we will get here minus 0.3, then we have 0, then we have minus 0.1, and we have 0.7. Similarly, at this point, delete this row, this column, and take determinant of the remaining elements, rather to form the minor here. So we have 0.9, here we have 0, then we have minus 0.1, and we have 0.7. Okay, I have calculated these stuff. Let me just write it here. So here we will have 0.9, 0, minus 0.3, and 0. Now at this position, delete this row, this column, take the minor of the other elements. That is, the other elements are 0, minus 0.3, minus 0.3, we have 0.8, then we have minus 0.1, minus 0.2. Okay, similarly at this, delete this row, sorry, this column and this row, and take the minor of the other elements. That is, we have here 0.9, minus 0.1, 0, then we have minus 0.2, and finally at this position delete this row and this column and take determinant of the remaining elements. So these will be the remaining elements. So we have 0.9, we have 0, minus 0.3, and 0.8. Okay, so this is our cofactor matrix. This is not done. Now we need to give the sign to these minors. Simple. First minor is positive, second the sign is negative. Here this is positive, then we have alternate sign, negative, positive, negative, positive, negative, and positive. Okay, then we need to solve this stuff. So let me rub this out. So we will be left with, so we have 0.8 into 0.7, so this is 0.56, minus 0 into anything, it will be 0, so we will be left with 0.56. Similarly here, since we have 0 here, 0 into 0 is 0, 0 into is 0, 0, so we are left with 0 only here. Similarly here we have zeros on this, so 0 into 0, 0 into 0, this is also 0. Here we have 0.3 into 0.7. Okay, so what will be it? 0.3 into 0.7, so this is 0.21, I guess. Okay, so let me check whether I have, is there 0.7. Yes, we have 0.7. So we have 0.7 on two sides. 0.3 into 0.7 is 0.21, 0.21. Okay, so 9 into 7 is here, 9 sevens are 63, so we will get here 0.63. Here we have 0, then we have its sign will be, where was I? It's positive obviously. Then 0.3 into 0.2 is 0.6, so minus is plus. Then we have minus, minus is plus, so we will get here 0.68. I have calculated it, 0.68. So then we have minus here, so 0.9 into minus 0.2 is 0.18. Okay, minus 0.18, minus, and the product of these two, so they will be 0. So we have minus 0.18, but we have this minus also, so it will become plus, and we will be left with 0.18. Okay, and similarly we will get here 0.9 into 0.8 is 0.72. Okay, I hope I make myself clear. There can be some technical errors in calculation, but I have tried to make this stuff easy. So 0.9 into 0.7 is obviously what I got here. this very matrix, and this is our cofactor matrix. Okay, so this is our cofactor matrix. Now to find the adjoint adjoint of this C is equal to simply the transpose of cofactor matrix. So taking transpose, simply interchanging rows with columns gives us the transpose matrix. So we have 0.56, then we write 0 0, then we have 0.21, 0.63, 0, 0.68, 0.18, and 0.72. Okay, so just interchange. If it is row, form it column, row, column, row, column. Okay, we got the transpose. Okay, so what exactly do we need to find out? So I have written it exactly that our x should be equal to, I minus a inverse into d. Okay, to find I minus a inverse, we need 1 upon I minus a, determinant of I minus a into adjoint of I minus a. Okay, and this adjoint C is actually our I minus a. So in place of this, I can write I minus a. Okay, now our inverse will be equal to I minus a inverse will be equal to 1 upon I minus a, which we got here 0.504, okay, into this adjoint which we calculated, which was 0.5600, 0.21, 0.630, then we have 0.68, 0.18, 0.72. Okay, so that means we need to divide each of these elements by 0.504, and what will we get? We will get a matrix something like this, 1.10 when we divide each element. So 0.5, 1.25, 0, 1.3, 0.4, 1.4. Okay, this is our inverse which we got here. So remember, there can be a mistake in calculation. That means there can be error in calculation, so you can just rectify me, and it can happen. After all, I am a human, and also I am just a student of economics. In that capacity, there can be some errors in calculation. But so what we were talking, so first we need to find out the inverse, and we got the inverse as this matrix. Okay, and then we need to apply this formula. Okay, so I will rub this out because I don't have the space. So our x final demand, that is x1, x2 and x3, will be equal to inverse, which is this matrix, that is 1.1 0 0 0.5 1.25 0, and then we have 1.3 0.4 1.4. To this we multiply the final demand. Okay, so this d denotes our final demand, that is f1, f2, f3, and our f2 is 0. That means there is no demand from no final demand from government householder sector or export sector. So all the output is used for self consumption and for the output as sorry, I I am stuck here. Since f2 is 0, that means there is no final demand, so all the output produced is used for the self consumption and as input for other industries. Okay, so f1, f2, f3 is being given as 20, 0, 100, 20, 0, 100. Okay, so for, what we need to do now, just solve this very matrix. How do we multiply two matrices? So simple formula is we write row into column. Okay, multiplying particular row with its column gives us the matrix multiplication. So we multiply each element of this row with each element of this column. So we have 1.1 into 20, 1.1 into 20, then we have plus 0.5 into 0, 0.5 into 0, plus we have 1.3 into 100. Okay, 1.3 into 100. Then we multiply this row with this column. So we have 0 into 20, 0 into 20, plus 1.25 into 0, 1.25 into 0, plus 0.4 into 100, 0.4 into 100. Similarly, this row with this column, so we have 0 into 20, plus we have 0 into 0, plus we have 1.4 into 100, 1.4 into 100. Okay, when you solve this, what will we get? We will get 1.1 into 20 is 120, 0, 0, so point, sorry, 0.5 into 0 na lagunya. This is 0. Multiplying anything, any number with 0 will make it 0. So 1.3 into 100 is 130. I guess I have done the calculation right here, or I have not made the calculation right here, so I am stuck here. So 1.1 into 20 is actually equal to 22. Okay, so this was another horrendous mistake. 1.3 into 100 is 130 in this column. So this is 0 into 20 is 0, 0 into 1.25 is 0, 0.4 of 100 is 40. Then we have this is 0, this is 0, 1.4 into 100 is 140. So we got here 152, 152. We have 40 and we have 140. Okay, that means x is equal to x1, x2, x3. That means the total output produced by each industry in this case will be 152 by x1 industry, you know, by first industry, 40 units of output by second industry, and 140 units by third industry. Okay, so another important thing that I forget to mention here was that we should be also able to satisfy here two conditions, what we call the Hawkins-Simons condition. What are they? Actually we have satisfied those very conditions, but I forgot to mention it here. First condition was our, you know, the determinant should be positive, so this was positive. And second condition was that the diagonal elements of I minus A matrix should be greater than 0. So I minus A matrix was this, its diagonal elements, rather principal diagonal elements should be positive. And here you can see these elements, these are called the principal diagonal elements, these should be positive. And here we can see they are positive. First was that the determinant of I minus A should be positive. Okay, and also the diagonal elements of this I minus A should be positive, and here you can see they are positive. So we have, you know, we have satisfied both the conditions. Okay, unintentionally, because I was not able to remember those very conditions. That is how do we solve the input output model. There can be some mistakes in calculation, obviously, so you know, but I was just trying to give you an idea how do you solve these type of questions. Okay, so to summarize this very stuff, okay, we were being given the technology matrix. Okay, technology matrix was something. First step was to find I minus a. Okay, this very matrix. Okay, after that, our final destination was to find the output produced by each industry. So let us say x1 denotes the output by first industry, x2 is the output produced by second industry, x3 is the output produced by third industry. It will be equal to simply the, let me write it here, uh, I minus a, its inverse, times the final demand. What was our final demand? F1, F2 and F3. Okay, so if I minus a was this, to get inverse we were required to find out I minus, that means that 1 upon I minus a, that means determinant of this matrix, and multiply it with the adjoint of this I minus a. Okay, so in turn to find the adjoint, okay, to find the adjoint, that is I minus a, we were, or rather we need to find out the cofactor matrix. Okay, so how do we form the uh, cofactor matrix? Okay, and cofactor matrix is formed by simply we if this element is here, so at this place we form the minor in such a way we mentally delete this row and this column and write this submatrix. Okay, kind of submatrix, that means we have 0 0.8, 0, obviously 0, then minus 0 0.2 and 0 0.7, and we do for all the places. Okay, to find the cofactor, here, so we mentally delete this row and this column and write this minor here. Okay, after that we solve this question. I hope I make myself clear in this video. Thank you. For more videos on mathematical economics, please subscribe this channel, like, comment and share also. Thank you.